Okay, so the presentation today is about the concept, an idea, let's say, that me and my fellow teammates at KPMG had together, and we worked hard to put it together. This is the device right here, if you're wondering. We're going to try to have a live demo later on. So, okay, some words about education. I want to give thanks to Danko Berezinchenko and Stefan Kula, and also Dan Kazaku, if he's going to watch the video. Thank you for the mic raising adapter. He's going to know why. Okay, something about me. I'm not neither root nor UID zero. I'm a senior information consultant at KPMG for 1 year now. I have a Bachelor of Engineering at the Polytechnic University, also a Master's, and I've recently started a Master in IT and C Security at ASE University. I've been a long time lurker on Romanian security team forum. I don't know if you know it. It's quite big in the Romanian market. We have some of the moderators and the admins here in the room with us today. Also, I have my CEH certification. I'm working towards my OSP and hopefully OSCE. You can contact me on Twitter or my contact info. So let's start. Where did the need for this kind of project appear? Well, it's simple. The security market in Romania, the consultancy security market in Romania, it's quite focused on traditional vendors for the main part. You go, you audit applications, you audit internal networks, you give the results to clients, they fix it, hopefully, and that's about it. And there's a trend going on for the past 3 or 4 years in the international markets, let's say, where people go and request red team engagements. Red team engagements are the engagements where us, the hackers, try to penetrate the client's network by every means necessary. We test the customer's responsiveness to threats, to dangers, to us mainly. And this project, the one right here, was started as an idea to create a Dropbox for Wi-Fi testing in the client's network that we'll see later on how we thought of it being delivered. It's a little hint there. So you may ask, why Wi-Fi as an attack vector? Why indeed? In the last month, does anybody recognize that logo? Okay, if you don't, I'll let you know, it's the logo designed for the track attack. The attack against WPA2 clients, which, let's say, rendered even the WPA2 enterprise-grade networks unsecure now. And the classic handshake attacks and the other WPA2 attacks. We have an expectation. Who recognizes that? Let's see some show of hands. Okay, that's Pineapple. It's a Wi-Fi oriented testing tool. Yeah, as you can see here, we're here. That's not what we came up with, but it was interesting. We made our version of a Wi-Fi Pineapple, and it works. We have 2 design principles: keep it simple and keep it cheap. Talking about the keeping it cheap part, we created it with what we had at hand. We didn't buy anything. So we had a colleague had a RaspberryPi. Another colleague had the wireless network adapter with monitorment, the alpha card here. I came in with a battery pack. We found a USB modem dongle and a SIM card with 3G and SMS support. The total is give or take $80, but as I said, we didn't pay anything because we already had it. As a side note, the pineapple costs around $100+ if you can find it. It's pretty hard to find, at least in Romania. The other design principle we had in mind was keeping it simple. We wanted an SMS communication channel that the pineapple didn't have because it consumes less power, because it was battery powered, if you remember. We had to design predefined commands because it's easier to use. No one wants to type commands on the phone, long commands. To implement as little third-party software as needed, and use open source because we're open sourcing our scripts and our work and our device design later, and you guys can use it also. Why the SMS communication channel and how? Well, this is an example. Actually, the help of the software. As you can see, it's not pretty because we encountered difficulties with encoding. But let me tell you how we implemented this. We used this 3G dongle here, as you can see. I'm not doing a commercial for 3G, but we used that dongle and our phone to send SMS commands to it. And on the RaspberryPi, we have Gamma SMS daemon. Gamma SMS daemon is a Python library or software that knows how to pull SMSs from that dongle and also send SMSs easily. It connects to it in a serial way and communicates with us. The why part now. Why we chose SMS? I told you, because it's a low energy form of communication. If we had used 3G in this device, the battery packs wouldn't last. They would die half a day, tops. So, as you've seen there, we have some predefined commands that I told you earlier. Help, password, if config, won't start, won't stop, shell, get SSID, get client's SSID, targeted authentication, and some more. Let's pass through some of them. These are almost all of them. First one, authorization. I blurred out the password we use because you're going to see the number we use later on. You shouldn't be able to use it. You cannot leave a device like this open for everyone to access. So authentication and authorization was a big step for us to implement because a device like this is powerful. Inside any network can be used as a foothold. So we did something pretty simple. We created a passphrase that once sent to the device and received by it, the script we made inserts our number into the authorized table in the database. Okay, let's move on. If config, it's the classic Linux command, no? We needed this because it's one of the prerequisites when you start your Wi-Fi card in monitor mode. You have to specify which interface is going to be used, or more correctly, which interface supports monitor mode. So with this command, when running, we receive a list of interfaces available on the device. Moving on, you have to start, as I said, a monitoring mode on the Wi-Fi card and also stop it because monitor mode consumes more power and we want it to be in there for a bit more time, as you will see later on. So it's simple. We created a parallelized script So we are able to open the monitoring on the interface and run other commands. And also the noise. I forgot to tell you, when each command is processed, we will receive an SMS back telling us it executed successfully. If no SMS is received, guess what? It's not working. Two important commands, get SSID and get clients on the network. This is our focus. We're inside the customer's network, let's say, the target. We first do a recon of the networks available in the place or device netted and get the list of those access points available to us. And get the clients that are registered to that network. As you can see, we opted for a version of opening a screen with that runs the commands we need. In this case, AirDump, well-known Wi-Fi testing suite. And we chose this because it was easier to kill the process than from inside Python. At least for me, my coding skills. Another command we implemented was the targeted authentication. As you know, inside WK2 attacks, targeted authentication is a way you force the user to reconnect to the AD, which it was connected to. And in that reconnection process, you grab the handshakes used in the negotiation. Something interesting about this command. I only posted the output, the snippet in the loop used when it's run continuously, because maybe we want to run it over and over again until we obtain a handshake. Because not always you obtain a handshake when you authenticate somebody. We used here the WK clean program to reduce the size of the capture file and only analyze when using Parrot. I don't know if you know it. Parrot is a tool that analyzes captures, cap files, and it tells you if you got a clean handshake or not, or half handshake, some things like that. So by run, the problem was that Parrot took a lot of time to execute. When I say a lot of time, 5 minutes on a capture obtained in 30 seconds. It's too much. And it consumes battery. Okay. If we obtain a handshake, then the loop is exited, and we receive a message that the handshake has been captured. Another option in Wi-Fi attacks, some of you know, is masked authentication attack. When you select a channel, a Wi-Fi channel, from 1 to 11, 13 in some countries, and you authenticate anyone on that channel, no matter the access point, and they all try to reconnect. And by doing this, you have more chances of capturing handshakes. It's logic. Okay. So it's faster to find a good handshake. A problem we identified while doing this was the following. A RaspberryPi and its processor don't handle the authentication very well. So we did some trial runs to sample the time, the maximum time we can leave MDK free running. MDK free is the tool to mask the authentication. So we sampled, we did some tests, and we realized that we can only leave MDK free running for about 15 seconds. After that, the processor freezes, and the script freezes, and the Raspberry Pi restarts. So that's about it here. Back connect. this is a pretty interesting feature, let's say. As I told you, we couldn't use 3G for long on the device because the battery would have been depleted very fast. And we want to do these types of attacks again and again and again until we succeed. So we had an idea. Let's make it connect to us. And to get the capture files, because we cannot do the processing on the Pi. The processor is weak. We don't have graphical boards. We cannot crack the password. So let's make it connect to us via reverse SSH tunnel. Connect to it, get the capture file, which is reduced, if you remember, and crack it on our side. So we came up with this function, backconnect. A problem we identified here was that there were two demons trying to use the USB dongle at the same time. And if you know, you cannot do that. So we bypassed this by stopping the SMS demon while I receive the command. It's pretty risky now to do that. Open the other demon and connect to the internet via 3G, and then connect it to us. And as a fallback, if it could not connect to the APN, we made it stop the 3G dongle and restart the SMS service as a fallback. Another command that's useful in attacks is the evil twin one. I believe many of you know the evil twin attack in Wi-Fi. You create an access point with the same MAC address and the same SSID of very big one, and you authenticate the people and make them connect to you. Another two features that you will find on this slide, on this presentation actually, because I implemented them last night and didn't get time to talk in the presentation, is the following. Remote copy the capture file back to us because it's faster. And another one is connect to the Wi-Fi that we cracked the password so that we can use it as a jump point inside the network. And now for the fun part. It should be fun. There's a method that I didn't tell you about. So distracting. Kaboom. No. I researched some ways to make the Raspberry Pi destroy itself. It seems that you cannot do that by itself. You have to have another component present, an actuator or something that fries the CPU. From inside the operating system, there are too many ways to prevent it. So what did I do? I encrypted the SD card with looks, and I implemented the subdestruct method, which removes everything from the root directory, and it doesn't preserve root for you Linux geeks out there. Okay, moving on from the commands. I guess I bored you with all that code. The third-party software we used was Python. Why? Because it's fast to develop in Python. I hope you will agree. We used GNU because the easiness to interact with the SMS dongle. We used AirCAG because it's widely used. It's very well documented. We used MySQL to store SMSs in the database. We used Sakis3G, which is the software we use to interact with the dongle to connect to the internet, to the access point. And Raspberry on the device. And now I want to present you a fantasy, or rather, maybe it was tried already, a real-life scenario about deploying that little device in there inside consumer networks, customer networks, sorry. The plan we thought of was to scout Facebook, well, first LinkedIn, and find high-ranking employees of the company that we targeted on LinkedIn. Then befriend them on Facebook, on Twitter, on Instagram, on all social media outlets, and see who is on vacation. After that, we choose a target. And it's simple as sending a packet via DPD, fan courier, etc. to that person, already paid for. To what happens? Well, the courier goes to the front desk reception and says, I have a packet for Mr. X. The receptionist or the reception guy checks his computer and sees, oh, but he's out of office. But he's the vice president of something. I don't want to call him. I don't want to disturb him on vacation. What does she do? Okay, she tells the courier, okay, I'll take the package and I'll sign for it. And now you are inside the building. You don't have to sit outside in a van when it's cold outside. You don't have to use high gain antennas to do that. You are inside the building. After that, the classic attacks start. You authenticate people, you capture handshakes. You crack the password with a Wi-Fi. Or not, you create a fake AP. Make people connect to your access point. When they connect to the access point, you can go 2 ways. Create on your Raspberry device there, that moves fast because it's inside the network, it's there. Scam site, fake intranet page. Sky's the limit when you're doing phishing. You can do a capture portal. And the first solution, you can just sit there and start a tool named Responder. I don't know how many of you know Responder as a tool. Responder as a tool responds, as the name says, to every bad request made on the network. Every wrong DNS entry, with what it responds, with MTLM challenges, with basic authentication ports that many companies use in their intranets. It serves by default vpat.dat files, the proxy settings. So there's the sky, and you, with that, just owned a lot of PCs and the whole network, maybe. Maybe you can get a local admin somewhere. It's possible, it's not unheard of. Okay, I'm very thrilled and emotional about the next slide, because I'm going to try and make a live demo, a quick demo, and I hope that this works. I hope I didn't bore you with anything like that. Just a moment so I can set up. I have to show you the screen of my phone. And it's a little bit tricky. Let's hope it works. It's not working. The screen share is not working. Okay, so the quick demo is not working today. I had some problems earlier, and I don't know, it's not working. Leave it like that. You're gonna have the source code and every tools used in developing this, and you can, if you have something like this at home, which I'm sure many of you have, could set it up and try it, because it's really simple and intuitive. Let me talk about further developments now. Write cleaner code, that's a mantra to myself. You saw the code earlier on the slides. Write cleaner code. Minimization, that's AppMap. Make it smaller. Instead of the 3G dongle, use a 3G driver for the RaspberryPi. That costs around $40. Instead of the big old Alpha, buy a nano card and use that for attacks. Minimization. Instead of the big Raspberry Pi, you could also use a Raspberry Pi Zero, which is small. As I told you, this is what I have at hand, this is what I did. I don't know if any of you went to a presentation my colleagues did earlier about Roby the robot and some hacks against it. Maybe you can strap one of these on the robot and make it go inside the company in the fence. Why not? Maybe you can use a drone to drop it off. This guy's the limit.